Hi guys. So today we're going to work on 12.1, the Pythagorean Theorem. Now you're going to be hearing a lot about this one. It has to do with triangles and we use it all the time, and you'll be getting it in high school over and over and over again. The upshot of the Pythagorean theorem is for a right triangle, that means one of the angles is 90 degrees. So for a right triangle, that means it looks like this, or it looks like this, or it looks like this, or what do they do sometimes? Sometimes they do this. So long as it has that little box in the corner, it is a right triangle. This is only true for right triangles. This is not true for every single triangle ever, okay? This is what the Pythagorean states. A squared plus b squared equals c squared. That is the Pythagorean theorem. A squared plus b squared equals c squared, where a and b are the legs of the triangle, and c is the hypotenuse. Now, oh wait, I spelled that wrong. Sorry guys. Hypotenuse. Okay, so on an actual triangle, if we're looking at it, let me draw a triangle right here. This is a leg. This is a leg. Okay, that's a leg. That's a leg. That is the hypotenuse. It does not matter which one you decide to call what. If you want this to be A and this to be B, that's fine. If you want this to be A and this to be B, that's fine. This is always C. You see how it's so, this is always C. You see how it's so much longer than the other two? It is always C. That would be C, that would be C, that would be C, that would be C. The long one is always the hypotenuse. Always, always, always. So let's do some problems with this. Let's say that we have a triangle. I'm going to draw another triangle for the purposes of our doing it. So let's say that we have this triangle. And I know that this side is 3 inches. I know that this side is 4 inches, and I want to know what this side is. So I have a squared plus b squared is equal to c squared. I'm going to make a the 3. So I put 3 squared plus 4, which is the b, 4 squared is equal to c squared. And then I start using my PEMDAS. Exponents go first. So 3 squared is 3 times 3, which is, let me do this in a different color, which is 9, plus 4 squared, which is 4 times 4, which is 16, is equal to c squared. We don't know that yet. 9 plus 16 is 25, which is equal to c squared. Now, the way you get rid of a square, is you take the square root. Square roots cancel out squares. So if I take the square root of 25, I'm asking what times what is equal to 25? And I know the answer is 5, so c is 5. And I actually picked this one in particular with the 3 and the 4 because I know that that is a triangle that always gives us a 5, a 3, 4, 5 triangle. It's really common. You're going to run into it over and over and over again. They use it a lot. We can solve any triangle that way. We can, if they give us the hypotenuse, we can solve for one of the legs. If they give us both the legs, we can solve for the hypotenuse. Let me do another one where they give us the hypotenuse so we can look and see what that looks like. This time I am just making up the numbers. I have no idea whatsoever what it's going to end up being. Yay! So let's make this one a, let's say that this one's a 5. And this one over here, let's make it 10. And then I don't know what that other side is. I have no idea what the other side is. Could be anything. So I go over here and I do my Pythagorean theorem. A squared plus b squared is equal to c squared. I'm going to make the 5 the a just because it comes up first. No other reason than that. You could make it the b if you want to. It really doesn't matter. So I have 5 squared plus b squared is equal to 10 squared. So once again, I'm going to use PEMDAS and do my squares first. 5 squared is 5 times 5, which is 25, plus b squared is equal to 10 squared, 10 times 10, which is 100. And now I can sit here and now I have 25 plus b squared is equal to 100. The 25 is bothering the b, so I'm going to get rid of that first. It's a positive 25, so I'm going to subtract 25 from both sides to get rid of it. 100 minus 25 gives us 75. So I now have b squared is equal to 75. And I'm going to switch my color so that you guys can see this. In order to get rid of that square, I have to do the square root. Okay? So I am going to do the square root. I then have b is equal to, and I'm getting out my calculator again, square root of 75, which is, according to my calculator, 5 the square root of 3. Okay, so how did my calculator get 5 the square root of 3? We probably have a lesson a little later on where we get into that one. I actually do know how it ended up being 5 the square root of 3. But for right now, 5 the square root of 3 is perfectly fine as an answer. Or you could have just put down b is equal to the square root of 75 because we do not know what times what is equal to 75. it doesn't actually, that isn't one that we know. So either one of these answers is just fine. Your calculator will give you this as your answer. If we're just thinking inside our head, we will end up with this as our answer currently. I'll explain how to do this one later. All right. So let me see. All right. So now it wants us to know how to do it with a 3D object. The other thing that we're doing in this section is 3D objects. Now, they talk about 3D objects, but really all they mean is rectangular prisms. So they mean boxes. So if I have a box, yeah, and I can go dot, 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 dot. I can do that with it, okay? So I can figure out how far it is from this corner to this corner using the Pythagorean theorem. So we're going to cut straight through the center of it. We're going to use a couple of other parts inside it, though. We are going to make a little imaginary triangle right here. And it's going to go up to there. So we have a little imaginary triangle inside there. And we're looking for the hypotenuse between that triangle. First thing we have to do, though, is worry about this bottom part. So I'm going to pull it out over here, okay? This is the bottom of our box. This is not actually a parallelogram. It looks like it should be a parallelogram. It's not. The only reason it looks like a parallelogram is because we're trying to do 3D perspective. It is actually a rectangle, just like this. And then the line that is cut between it is literally cut straight between it. So we are making two triangles. Okay, this is at the bottom. We are making two triangles out of this. All right, so if I know what all these lengths are, so let's put some lengths on here to get this going. If here is, let's say that this is it's a 3x3 box, and then the length is 12. Let's go with that. So 3x3 box, the length is 12, the depth is 12. So we have a square on either side. That's what we're dealing with. If I come over here, I know that that is a 3, because that's the bottom right there. And the side is 12. So I end up with a 3x12 rectangle. I don't care about the whole rectangle. All I care about is what is that line? That's my question. See, I just pulled out this one rectangle, this one triangle out of it. That's all I care about. Just what is that one line? So because this line is a 12, so is this line. So that becomes a 12. Because this line is a 3, so is this line. So that line is a 3. I can now take my Pythagorean theorem and find out what that is. That's my long line. That is my hypotenuse. So I rewrite it. A squared plus b squared is equal to c squared, where a is 12, b is 3, and I don't know what c squared is. Okay? Now I can do 12 squared. 12 squared is 144, plus 3 squared, which is 3 times 3, 9, is equal to c squared. So 144 plus 9 is 153, right? is equal to c squared. Once again, I need to do what I did up here. I have to do my square root. Let's see what it shows up as. Square root, square root. So I end up with c being equal to, well, let's see what it comes up with. Square root of 153 equals, okay, so it is either straight up the square root of 153, or your calculator will give you 3 the square root of 17. If you go over to the SD, if you point that, it will give you 12.37, so on and so forth. Okay? So you can get out to an actual decimal number. I'm not entirely sure that's what we want to do, though. I'm going to have to think about that one a little bit, because what we want now is we want a different triangle. We are now searching for a different triangle. This triangle, the bottom, is the square root of 153. So you see the line going through right there. That's the line we just found. The back, the other back, is 3 because it's the same as everything else's. And I don't know what that one is. Are you with me? Because this is the one that's going from this point to this point, okay? So we have from this point to this point. We already know that. We know every line is going to be 3 because it's a rectangle. So going from this point to this point, that is now here to here. Okay? So once again, we take our a squared plus b squared is equal to c squared. Let me move this over a little bit. Okay. Still with me? Our a squared, let's go with the 3 squared, plus b squared, which is the square root of 153 squared, is equal to c squared, which we do not know. Okay, this is actually easier to do than the other one was, so we can do this pretty quick. 3 squared is 3 times 3, which is 9. Square root of 153 squared. Remember, square root and squared cancel each other out. So we are just left with 153 is equal to c squared. You see why I kept it that way? There's no point in worrying about it. So now I do 9 plus 153, which gives me 162, equals c squared. What I have to do to both sides is the square root, sign to both sides, and then I am left with c is equal to, let's see what the square root of 162 is. Okay, so we have either c is equal to the square root of 162. Let me write it up here. C is equal to either the square root of 162, your calculator will give you 9 square root of 2, or 12.72. All of those are correct answers for C, for this line right here, going from this corner up to this corner. We have other problems like this inside the book. I am going to go, How about we go to, I would just be working through it a second time. We're going to be working through it a second time inside the book. So how about we go do that now? All right. So I'm going over to page 377 inside your book. Just a second. Okay. So in your book, you have something that looks a little like this. Theirs is much prettier than mine is because mine's freehanded and theirs was done by a computer. But they want us to have these triangles where one leg is shorter than the other. Trace it onto a piece of paper 4 times, arranging them as shown. For each triangle, label the shorter leg A and, the shorter leg A and the longer leg B. So this is A, B, A, B, A, B. Okay? And then label the hypotenuse C. C, 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 C. There we go. All right, so now it wants to know what is the area of this unshaded square? Well, it's C, length, times width, which is also C. So area equals C squared. Do you see how I got there? Area equals C squared. Trace your original triangle onto a piece of paper 4 times again, arranging them as shown. Just a second. Okay, so there is my 4 triangles drawn into little boxes at the bottom, which are then inside the big box that's the same size as this big box. All right. Then what is the area of the unshaded square at the top right? And then at the top left. Okay, so this is angle A, B, C. So A is here and B is here. This is B, this is A, this is B, this is A, this is C, and this is C. Okay, so I have all of my shapes listed. It is the area of the unshaded, so right here. What will that area be? Well, it'll be, because that's a box, that's actually a square. So it is B squared. No, that's not true. A times B is this area down here. Give me a second. All right, so I know that even though it doesn't look right, I think it's because I wasn't doing this with a ruler. So they're saying that this is a square. If this is a square, that means that it's B times B, which is B squared. If this is a square, if this up here is a square, it means that it's A times A, which is A squared. Okay, so if that's what they're trying to show, they're trying to show that the empty space here, so area is B squared, area is A squared. Okay, that's what they're trying to show. So what is the total area of the unshaded regions? Area is equal to A squared plus B squared. But over here, we already decided that the area was equal to C squared. And so we can substitute the area of one in for the area of the other, which gives us A squared plus b squared is equal to c squared. Although I did those all with capital letters and I was supposed to do those with lowercase letters to give us our a squared plus b squared is equal to c squared. Okay, so that's what we were supposed to end up with. 378, number 1, explain whether the figures in B and D have the same area. Okay. Number 1, yes. I drew the same triangle 4 times in B and 4 times in D. So if we draw the exact same shape, the exact same number of times in both of them, we will end up with it being the exact same. Number 2, explain whether the unshaded regions in figures B and D have the same area. Yes, they are the same amount of empty space as each other. Number 3, write an equation relating the area of the unshaded region in step B to the unshaded region in step D. So here they're asking us to go unshaded is c squared is equal to the b squared plus the a squared. Or we can shift it around to a squared plus b squared is equal to c squared, which is what we normally use for the Pythagorean theorem. Bottom of 378, using the Pythagorean theorem. So they're giving a couple of different triangles and asking you to find the hypotenuse. Then they're giving you a triangle that has one side and a hypotenuse, and they're asking you to find the other side. So let's skip up to number 4. Our triangle looks like this. We have a 30 and a 40. I'm going to do a squared plus b squared is equal to c squared. A squared is 30 squared plus b squared, which is 40 squared, is equal to c squared. I'm going to do my calculator. On 30 squared is 900 plus 40 squared, which is 1,600, is equal to c squared. 900 plus 1,600 is equal to 2,500 is equal to c squared. I can then get rid of the squared on the c by doing a square root both times to both sides. So square root of 2,500 is 50. So C is 50. Other one, number 5. Little skinny triangle has a 41 here and a 40 here. Again, a squared plus b squared is equal to c squared. In this case, the a squared is the 40. I do not know the b, so I'm leaving it there. And the c squared is the 41 squared. So once again, 40 squared, which we'd already done, 1,600, plus b squared, which we don't know, is equal to 41 squared, which is 1,681. In order to get that 1600 on the same side as the 1681, I have to subtract minus 1600 minus 1600, which leaves me with 81. B squared is equal to 81. I can take the square root of both sides, which leaves me with B is equal to, what times what is 81? 9. So in that case, my B is equal to 9. All right, the bottom of 379, it goes through an example of how to cut a rectangular prism apart to use the Pythagorean theorem so you can find the length from the topmost corner to the bottommost corner, cutting straight through the entire thing. And so that tells you how long of a tube you would be able to fit inside that box, because you can fit it from the topmost corner to the bottommost corner. So let's try number 6. I'm actually going to get a separate piece of paper for this one because it's going to be a little long. So number 6 says, Tina ordered a replacement part for her desk. It was shipped in a box that measures 4 inches by 4 inches by 14 inches. What is the greatest length in whole inches that the part could have been? So it has our, I'm putting this on the side for the moment so I can do a sketch better. And then we have a whole ton of little lines going on inside like that. And then the actual ones that we're worrying about, I am going to put in, no, not red. Red wouldn't look good. Purple. I'm going to put in purple. So we have our bottom line, which we're worried about. And then we have the rest of the triangle, which is right there. Okay. So the purple triangle is what we're actually trying to find the measure of. That's what we want the measure of. We want the measure of that line, the hypotenuse of the purple triangle. Okay? In order to find that hypotenuse, though, we need to know what this side is first. So we have to jump through a couple of hoops to get that side. Here is the bottom of the box. That is the bottom of the box. Oh, I probably should have done it in brown, shouldn't I have? And the side that we're trying to find is right there. It is between the two parts of the bottom of the box. Okay, so let's see what we got going on. It says the bottom has a 4 there and a 14 here. Okay, so we are making a triangle that is 4 by 14, because if that's a 4, so is that. All right? And if that's a 14, so is that. This is a rectangle that we're dealing with. So we start with a squared plus b squared is equal to c squared. A squared is 4. 4 squared plus b squared, which is 14. 14 squared is equal to c squared. 4 times 4 is 16 plus 14 squared, getting out my calculator, 196 is equal to c squared. 196 plus the 16 gives us 212 is equal to the c squared. Here's the thing. I don't think I'm going to worry too much about changing this back into a, what is c actually equal to, because if you remember, we're just going to have to square it again in a second. So now we have our triangle, our purple triangle, remember? This is the one that is going from this bottom corner all the way up to that top corner. So we're going from here all the way up to here, okay? That's where we're going. So that line is from here to here. That's that line. This line down here is the 212 that we just found. So I'm going to put down the square root of 212. That's what we just found. The square root of 212, that is what that line is. This line here, we're told at the beginning. It tells us how tall this box is. It tells us that this box is 4 inches tall. So we know that that's a 4. Okay, we are once again solving for C. So I'm going to write it over here. A squared plus B squared is equal to C squared. A squared is still the 4 squared plus B squared. Now B squared is the square root of 212 squared equals C squared. I don't know what C squared is yet. What is 4 times 4? 16. Plus, remember, square root and squared cancel each other out. 212 is equal to C squared. So let's go 16 plus 212 gives us 228 is equal to C squared. Now, it wants to know this. So we need to do the square root of both sides, because it wants to know what C is this time. It wants to know what the length of that is. The square root and the squared cancel each other out. So let's see what the square root of 228 is. 2 to the square root of 57. Okay, that's not what they want. This particular one, they want us to hit that S to D button. There's that S to D button. It looks like that on your calculator, S to D. And it tells us that it is 15.099668, and then probably 7755, something like that. But it only wants in whole inches. So it could have been 15 inches. That's all. Whole inches. Doesn't care about the decimal. It only wants the whole number, which is 15. So that's all we're putting down. All right, let's jump down to the guided practice. Number 1. Let's go with this color. Says the length of the missing side of the triangle. A squared plus B squared is equal to C squared. It tells us 24 squared plus 10, because that's the one that's not there, squared is equal to C squared. This is being a little weird, guys. Okay, so let's figure out what is 24 squared. 24 squared is 576. 10 times 10 is 100, is equal to C squared. 576 plus 100 is 676, is equal to C squared. And so let's see, 676, the square root of 676 is 26. So C is equal to 26. Number 2, Mr. Wu wants to ship a fishing rod that is 42 inches long to his son. He has a box with the dimensions shown. Find the square of the length of the diagonal across the bottom of the box. Find the length from a bottom corner to the opposite top bottom corner to the opposite top corner to the nearest tenth, and will the fishing rod fit? Okay, new sheet of paper. Number 2, the diagonal, the bottom diagonal across the box. So we're looking for the hypotenuse for the bottom of the box where we have sides. This is the bottom of the box. And we're looking for, well, that's half of the bottom of the box. I cut the bottom of the box in half so that we could have our triangle. And we have a side that is 10, and we have a side that is 40. So we are going to find that. That's the first thing that we need to find. A squared plus b squared is equal to c squared. A squared is 10 squared plus b squared, which is 40 squared, is equal to c squared. 10 squared is 10 times 10, which is 100. Plus 40 squared is 4 times 4, 16, plus the extra 2 zeros, equals c squared. 100 plus 1600 is 1700, is equal to c squared. I now need to do, well, yeah, okay, fine. Square root of each of them, so I end up with c is equal to the square root of 1700. Yeah, not worth it. C is equal to the square root of 1700. Okay, so that's what I'm going to put down as my c. That's the how much the bottom is. Then I am going to come over here and I am going to make my transversal. So this is the one that is going from the top corner down to the bottom corner. Top corner to bottom corner. Okay, that's what this triangle is showing. It goes up 10 inches, so that's still a 10. It goes across what we already had written down over here. So the square root of 1700. Okay, and we're once again searching for that. So a squared plus b squared is equal to c squared. A squared is once again 10 squared plus b squared, which is the square root of 1700 squared, is equal to c squared. 10 squared is 10 times 10, which is 100, plus square root and square cancel each other out. So we are just left with 1700 is equal to c squared. 1700 plus 100, or 100 plus 1700, gives us 1800, which is c squared. I now need to do a square root to get rid of the square. And let's see what c is equal to this time. Square root of 1800 is, I'm going to move it over to, I'm going to use that SD to move it. So I have 42.4 because it wants it to the 10th place. 42.4 inches. His fishing rod is 42 inches long. Will it fit? We have 42.4 inches available, so yes, it will. It'll be tight, but it'll fit. Number 3. State the Pythagorean theorem and tell how you use it to solve problems. A squared plus b squared is equal to c squared. I can plug in either I can plug in two sides of a right triangle to find the third side. Always, 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 always. All right, that is the end of the guided practice. I think you can handle the rest of it. Have a good day. See you later. Bye.